Right. So yes. Well, thanks very much for the invitation to speak on this topic. As Catherine says, it's a huge undertaking, and we're halfway through the process of writing the technical chapters. So this won't give any results. This presentation is just about the method that we're using to actually undertake the risk assessment, and explain where the evidence is coming from and how we are using it to assess the risks. I just want to start by acknowledging my the chapter leads, who are the core team for writing the chapters. So as well as myself and Catherine, who you've seen, Julia Slingo, who's a former Chief Scientist of the Met Office, he's leading on the climate science area. Paul Watkis from Paul Watkis Associates is leading on the economics and the method. Then we have Pam Berry from the University of Oxford, Ian Brown from Dundee, Ruth Wood from Manchester, Lee Chapman, David Jaroszewski from the University of Birmingham, Shari Kovats from London School of Hygiene and Tropical Medicine, Rachel Brisley from the Steer Group, Svenja Szyminski from London School of Economics, Andy Chandler from Leeds University, and Tim Benton from Chatham House. But as well as that core team, we also have 42 contributing authors, and maybe more for them as we evolve the chapters further. 17 additional contributors from the Committee on Climate Change themselves and the Secretariat and our expert advisory panel, and then numerous researchers doing specific analysis to feed into this, either contracted by the CCC, as Catherine described, or in other programs such as the Met Office Core Programme, Met Office Hattie Centre Programme, or the Climate Resilience Programme. So I'm sure many people in the audience are amongst some of these groups, so thank you very much everyone for all your efforts so far, but we still have a long way to go. The purpose of the CCRA, as Catherine described, is under the Climate Change Act. It's about informing adaptation. So basically, based on our latest understanding of current and future risks or opportunities, so there may be opportunities from climate change for the UK, and a knowledge of vulnerability and adaptation, what should the priorities be for the next national adaptation programme and the adaptation programmes of the devolved administrations? So it's about informing government about where to prioritise planning and investment and so on for putting in place adaptation to climate change. And the process, and just to show where this all fits in, Catherine's covered this a little bit already, but basically the bulk of it is the technical chapters, including the assessment of the urgency of adaptation action, and that's informed mainly by existing academic literature. There's a raised hand I can see. Is there an issue? I can see people raising hands, but I don't know what to do with this.
Hang on. I can't see any raised hands.
Okay, well, I'll carry on, and perhaps if there's a message, then people.
Oh, that's fine. It's okay. There's a cat on the keyboard.
Excellent. Oh, brilliant. I love it. So yeah, the technical chapters are informed by mainly by existing literature, and from input from stakeholders, such as government departments and key organisations in charge of, say, infrastructure and so on. But also there's some new analysis, some of it commissioned by the CCC, some of it from elsewhere. This will feed into our assessment of the urgency scores, and that will inform the synthesis report that CCC will write. And then that itself will underpin the government report, which is written by DEFRA on behalf of the government, and then that goes to Parliament at the final stage of the process. So quite a sort of long chain of information and layers of synthesis. And one bit of background I wanted to put out there now was the framing of risk, how we're determining and how we're defining risk here. We're using the definition which the IPCC, the Intergovernmental Panel on Climate Change, have used for some years, which is where a risk is could be considered a combination of the hazard, so the change in, say, extreme weather or flooding or something, combined with exposure, which is where people or assets or species or ecosystems are in harm's way, and the vulnerability of these things, so how sensitive these people or assets or ecosystems are to the change in the hazard. So that combination is the risk. And that's how we define the risk. And as I said, we're also looking at potential opportunities as well, and that's sort of defined in a similar kind of way, if you like. So both changes in climate and changes in socioeconomic conditions and so on. And we're grouping these into 5 risk areas: natural environment and natural assets, which has 22 specific risks. Through consultation with government stakeholders, we've identified a list of 65 risks in total, which we're specifically addressing. So 22 of those are in natural environment and natural assets, 13 are in the infrastructure category, another 13 are in the health, communities and built environment category, 7 are under business and industry, and 7 are in international dimensions. So international dimensions means where climate change elsewhere in the world is impacting on the UK, such as through trade or security or humanitarian responsibilities and so on. And obviously some of these will kind of link with each other and overlap as well, so that you can't perfectly cut it down, but you have to have a framework somehow. So this is the way we're looking at it, but we are also considering interactions between risks and cross-cutting issues. So just to give you a flavour of what these risks are, I'm not going to list all 65, but I thought I'd just give you examples of a couple from each one. So we've got risks to terrestrial species and habitats from changing climatic conditions and extreme events, or opportunities for agricultural and forest productivity from new alternative species becoming suitable due to climate change. Under the infrastructure category, a couple of examples: risk to infrastructure services from river, surface water or groundwater flooding, or risk to public water supplies from reduced water availability. A couple of examples from health, communities and built environment. We've got risks to health and well-being from high temperatures. Conversely, there's also an opportunity from increased temperatures as well. Potential for reduced cold deaths and so on is also included as a separate category. And then risks to people, communities and buildings from flooding. Business and industry risks and opportunities, things like risk to business sites from flooding, or risk to business from reduced employee productivity due to infrastructure disruption or higher temperatures. And then finally, international risks. It's things like risk to food safety, quality and supply from climate change overseas, risk to the UK from climate-related international human displacements, and risk to the UK from international violent conflict from climate change and how that might impinge on the UK. So that's a sort of just a small subset of the 65 risks we're looking at. And the way that we're assessing the urgency of adaptation to these risks, we're just giving it a very simple score, which tells the government how soon adaptation action is needed. So for each individual risk, we categorise them into either more urgent or less urgent action. On the more urgent side, it's either more action is needed, so more adaptation action. This is independent of any mitigation stuff. It's assumed that mitigation policy is ongoing and will continue to strengthen and so on. So this is independent of that. This is about adaptation action. So more action needed is the most urgent category, or further investigation, and you'll see later on what that means. But basically, it's we know that more adaptation is needed, but we can't say specifically exactly what, but it needs to be investigated as a priority. On the less urgent side, the outcomes could either be sustain the current action on adaptation. There's some adaptation is already happening, and if that's already in place and sufficient, then the action is just to sustain that. Or it may be that it's not clear what is needed yet, but it doesn't seem to be urgent, so it's keeping a watching brief. So the aim is to come up with one of those 4 scores for all of each of the 65 risks. So there's a step-by-step process to addressing this. The first step is to ask what is the current and future level of risk or opportunity. And if it's assessed that the level of that for this particular risk in question is low, then we go to one of the less urgent outcomes, and that's the scoring for that one. But if the current level of risk opportunity is either high, medium, or unknown, and I'll say a bit more about exactly what this means in a minute. If it's high, medium, or unknown, then the question then becomes, is the risk or opportunity going to be managed, taking into account government commitments and other adaptations, so stuff we already know about, what current policies are already in place to adapt to climate change. And if the answer is that there is a less significant shortfall in adaptation, so i.e. Adaptation is sufficient, then again we go to the less urgent outcomes. But if there is a significant adaptation shortfall, so there's barriers to adaptation or failures, or the policies aren't in place, then the question then becomes, are there benefits to further action in the next 5 years over and above what is already planned? And the 5-year timescale is important because that helps with prioritisation. Does the adaptation need to start now or within 5 years, or could it be later? So again, if there's a less urgent outcome for that, or a more urgent outcome. So if the answer is yes, then we go to either the more action needed or the further investigation categories. So we do that for each of the 65 risks that we're assessing. So a bit more detail on what these mean and where the evidence comes from. First question is, what is the current and future level of risk opportunity? So there's a lot of evidence on that already. We see impacts of extreme weather, for example, of many kinds, of drought, flooding, high winds, and so on. And there's a lot of work going on into attributing these to climate change and to establish whether they are a climate risk that is likely to increase. So without going into the details too much, the figure on the top right is from a paper in 2011 by Pardeep Paul and co-authors, which was the first one to show that there was an increase in the risk of heavy rain conditions that led to flooding. This was in autumn 2000. So they ran climate model simulations without man-made climate change, and then with climate change as it was in autumn 2000, and it showed the increased risk of a particular return period of daily runoff. There's been many other studies like that since then, so we have quite a strong evidence base of certain types of climate risks for particular weather hazards. But also there's been work going on about whether risks exist under the current climate, even if they've not actually turned into an actual impact as yet. So some work that the Met Office did for the National Flood Resilience Review some years ago looked at unprecedented events, and the bottom right figure briefly explains that. The paper by Vicky Thompson and co-authors for 2017. So the black line here is showing the time series of monthly rainfall in January, I think it was, and the red lines are showing climate model simulations reproducing that with different past climate histories that could have happened. And the point is, the heavy rainfall that did happen could have happened at any time, but it just didn't, just by chance. And it turns out there's other events like that could also happen under the current climate, but they just haven't yet, by luck. So that's an important sort of element of the current risk as well. So that's the sort of first step in what is the current risk and opportunity. So we give a magnitude score for the current risk, either high, medium, low, or unknown. And then we assess the future level of risk and opportunity. And this is where it starts to get very sort of, well, both uncertain and complicated. So there's many different ways in which climate change could pan out in the future. A standard way of looking at this is to drive climate models with different scenarios of changes in greenhouse gas concentrations, such as CO2 being the main one, obviously, but also methane, nitrous oxide, and so on. These are the RCPs, the representative concentration pathway, so changing CO2 concentration out into the future, and that's been used by the IPCC, Met Office, UK academia. Many groups around the world have been using this as a standard method of projecting climate change by using these input to climate models. And the new UK projections use these concentration pathways and the emissions scenarios that go into them. But that's a wide range of possibilities. What would we actually expect to happen under current policies? And this is a harder question to answer. And sometimes there's a rather over-precise kind of answer given to this, which we need to be wary of. One major sort of organisation which makes scenarios of ongoing emissions is the International Energy Agency, and that feeds into other assessments. And if you take their current scenarios, which go out to 2040, and then extrapolate them based on different assumptions, then that would suggest CO2 concentrations rising by somewhere around 550 to 700 or so parts per million by the end of the century. So somewhere around the second highest RCP concentration pathway, if you use the standard way of translating emissions to concentrations. But of course, there's feedbacks in the system as well. And an important paper by my colleague Ben Booth at the Met Office showed that the uncertainty in carbon cycle feedbacks can introduce a significant uncertainty in translating emissions into concentration pathways. And it turns out that even with a medium emissions scenario, you could get a high concentration pathway like RCP 8.5. So that's important to bear in mind as well. It's probably unlikely, but it's still possible at the end, tails of the distribution in that set of models. So the climate models that tend to get used for IPCC projections and in a similar way through the UK projections give a wide range of possibilities of future global climate changes, global mean temperature anomalies. Each set of colours shows the outcome for one concentration or emissions pathway. And then within each one, you can see there's a range of possibilities depending on which model is used. So this is using multiple climate models. The UK projections draws on this, but also the latest projections uses a large set of different variants of the Met Office model as well to cover a range of possible outcomes and to downscale those to the UK as well as looking globally. So if you looked at all those RCPs, you could get a very wide range of outcomes. If you use a standard assumption of what's viewed as current policies, you would expect that anywhere between around about 2 degrees global warming and 4 degrees global warming could be reached by the end of the 21st century. So that gives you kind of a core estimate of where global warming could end up. And we are using that as the core for the CCRA. But actually, if strong feedbacks were to occur in either direction, then it could be a wider range of possibilities. So we also need to account for outcomes above and below those as well. But the core of what we're doing is to assess risks at 2 degrees and 4 degrees global warming by the end of the century and pathways towards those. Because you have to have some way of standardizing it, so you're looking comparing like with like. But it's not all about global mean temperature, obviously. For the UK, what happens in the UK climate is clearly quite critical, and unfortunately there's even larger uncertainty in that, which makes the risk assessment more challenging. Although some of these uncertainties can now be quantified fairly well and even reduced in some cases. So on the left-hand side here, I've just shown some results from the latest UK CP18 projections for percentage change in summer rainfall intensity. And there's 3 estimates there for upper, median, and low estimate from different models in the set. So a wide range of possible outcomes, but potentially large increases in summer rainfall intensity by around the 2080s or so. But we're also looking globally as well for the international risks. So we're looking at important metrics might be things like heat stress risk. So when the wet bulb globe temperature, a combination of temperature and humidity, could reach levels which would lead to high risk of heat stress, say at 4 degrees global warming. But it's not all just about the physical climate, it's also about the socioeconomic scenarios which feed into the exposure and vulnerability assessment as well. So the standard projections for that, the SSPs are the ones currently used in most studies. But an important part of what we're doing for the CCRA is the socioeconomic implications of the net zero mitigation policy. The UK is committed to net zero emissions by 2050, which would inevitably mean changes to energy infrastructure, land use, and many other things. And those could affect some of the risks of climate change, and some of them will be vulnerable to climate change. So we're looking at the implications of net zero policies for UK climate risk as well. And as I said, most of the information on this comes from existing literature, most of which is based on UK CPO9 projections, the old projections for the UK, but also other climate projections as well. But the climate science has been updated recently and is still being updated. So I mentioned the UK CPA team projections. So they've been used to do some new analysis on water resources, flooding, and also some extra work on wildfire, interacting risks as well. All these have been looked at using the new projections. And we're also comparing the new and old projections in terms of the change in hazards. So we can see if any conclusions from the old literature need to be updated using a kind of expert judgment methodology for consideration in UK CP18. There's still time for additional input, such as from the UK Climate Resilience Programme. I know many groups are using the new projections there. And finally, we're also looking at implications of climate system tipping points for the UK in a very preliminary way as well.
Couple more minutes, Richard.
Thank you. Yeah. So the other 2 questions in the future risks is, are there any risks of lock-in? So are there any sort of decisions you could make for adaptation which would preclude any better decisions later on? And are there any cross-cutting risks in interdependencies? So that leads to our future magnitude score, again, high, medium, low, or unknown. And then step 2 is about how this is being managed. So what are the effects of current adaptation policy? Also, what are the effects of non-government adaptation? And what are the barriers preventing adaptation? And the main source of information for that is actually the stakeholders themselves. Some of it is in literature, but most of it comes from government departments with responsibility for certain areas, or from organisations that look after infrastructure, such as Network Rail, water companies, energy companies, and so on. So that's a key part of the process. And then finally, for other benefits from further action in the next 5 years, again, that relies on a lot of stakeholder input and experts within government and within the devolved administrations as well. So the Northern Ireland and Welsh Assemblies and the Scottish Government. And the questions there are, what types of additional action would address the shortfall? What are the costs and benefits of the adaptation? And this is where Paul Watkins's work on the evaluation comes in. And finally, this leads to this overall urgency scores, which involves subcomponents of different types of adaptation: no and low grade adaptation, climate smart design, or early activities to support future adaptation, or further investigation if we don't have a clear answer to any of those. And finally, what does this mean for the next CCRA? What are the big research gaps that still existed, because there's still a lot that we don't know, and what are the big picture questions, and what are the sort of transformational changes that might be needed over and above all this? So to finish, just to let you know the timeline of all this, we're still taking in new evidence. We'd like that by towards the end of August, because we're in the middle of, or starting to write the second order draft of our technical chapters now. We've had the first order draft out for review, had many comments back in. Thank you to anyone in the audience who provided comments, by the way. They're very useful. So we will send that out for review in November, and then do a final round of revisions, and the things will be approved, the chapters will be approved in March. And the synthesis report will then be written. It'll start sooner than that, but it'll be completed from March onwards and published with the technical chapters in the middle of next year. And then the government report will be laid before Parliament in January 2022. And that's a hard deadline because that's required by Act of Parliament. So anyway, that was quite a sort of whistle-stop tour of the method and the evidence, and I'll finish there. Thank you very much.